students, how are you all? I hope you all are fine. So welcome to the class, and this is going to be the part 3 of your chapter carbon and its compound. So already in part 1 and part 2 we have already learnt about the carbon, its properties, its features. So now it's time to learn certain chemical properties of carbon compounds and also certain properties of important carbon compounds, or you can say the functional groups as your NCERT suggests. So without any further ado, let's get started. So first thing first, the question is, why do we need to learn certain chemical properties of the carbon compound? We have already learned about the chemical properties of carbon. So carbon compounds is going to have similar properties as that of carbon. But no, since we have studied that carbon is very versatile in forming certain bonds due to its tetravalent feature, right, or property, and also by catenation it can form certain allotropes like diamond, graphite and certain other allotropes, right. I've already studied certain unsaturated and saturated hydrocarbons such as alkenes, and alkynes. We have learned that alkanes is known as saturated hydrocarbon because of the presence of the single bond, and alkenes are alkynes due to double bond and triple bond, right? They are unsaturated hydrocarbons. Moreover, we have studied about the functional group as well. We have studied that there in organic chemistry we learn certain functional groups include carboxyl group, carbonic acid group and hydroxy group and also ester group, and we have learnt about the ketone groups, nitro groups, etc. etc. We have learned these functional groups are involved in our day-to-day resources such as kerosene, oil, plastics, medicines, in which we can find these alkenes, alkynes and also the functional groups. So now it is very important to learn the certain chemical properties of the carbonic compound, because we never know the carbon which is getting bonded with certain other elements, how it is going to react. And when we apply in our day-to-day resources, that element or that compound is going to be eco-friendly with the nature or it will pollute it. So in order to know the applications of carbonic compounds, we need to know the chemical properties as well, because we need to know if it's harmful for our society, we are not going to use it, right? So that is why it become important to know about the chemical properties of the carbon compound, to which element the carbon is getting attached to, right? So for the application, we already know that carbon compounds is present everywhere in our day-to-day resources. So they are involved in processes like combustion, where the fuels get fully combusted, respiration, organic compounds, and even in the production of plastics, medicines and food. Carbon is very familiar compound which forms the fuel. Yes, the fuel which we use in our vehicles, right? So sometimes the carbon, which is present in the form of fuel, is generally goes through combustion. Now what do you mean by combustion? Combustion is actually the first chemical property of carbonic compounds. Combustion is like burning the carbon. So sometimes the complete burning of carbon leads to eco-friendly flames that is in blue in color. And certain times this carbon is goes through incomplete combustion, which result in pollution, which results in certain yellow-orange flames and lead to pollution, that we known as or we refer to as incomplete combustion of carbon. So many a times you have seen or observed that certain old vehicles or cars give out certain black sooty flame. You can see in the picture as well. We already know that this carbon is used as fuel inside the vehicle. So why does it is not burning properly? So we call this black sooty flame as carbon monoxide, which is the, you can say it is the element which is producing pollution in our environment. Now we are going to start with the chemical properties of carbonic compounds. So first property is combustion. Now what is combustion? Combustion is a chemical reaction in which the carbon compound reacts with oxygen. So we already know that whenever the element gets react with oxygen, oxygen is known for burning, right? So if you want to heat something or to burn something, oxygen gas is required. For example, the fuel which is present inside the cars is goes through the combustion where the fuel gets react with oxygen and gives out carbon dioxide, water and heat and light, of course. So certain examples were carbonic compounds, and for example the major common example is fuel. Fuel is a carbon compound which we usually use in our automobiles or vehicles. So how does this work? How does combustion works in the car? We are going to see. All right. So in the car especially there is spark ignition engine. Now what does this spark ignition engine do? Connected to the cylinder. You know the fuel in our car is made up of carbon plus air. Air has what? Oxygen. All right. So this fuel air mixture, this is going to spark or ignites the engine. So engine used to goes through combustion where the fuel is completely burned out. All right. That is known as combustion, which gives out, which makes it to start the engine. All right. Sometimes it happens where the carbon or the fuel is incomplete combustion, goes through incomplete combustion, which gives out certain black sooty gas, which is known as carbon monoxide. And this carbon monoxide leads to what? Pollution. All right. So this is a very common example where fuel is a carbonic compound which goes through combustion in our automobiles, and that is being used as for ignition the automobiles. Then the second most example is methane gas or the natural gas which is being used for cooking. So this methane gas as well now get reacts with what? The oxygen, and then it gives out what? Heat and light and carbon dioxide. So that is why we need the lighter in the kitchen to spark the light, okay? So that it can gives out heat and light. There are certain examples like combustion of methane. You can see in your NCERT certain reactions of methane has been given to you where methane gets react with oxygen gas and give out carbon dioxide plus water and the energy in the form of light. All right. And more other examples, combustion of ethanol. Ethanol here is acting as the fuel only. Always remember ethanol acts as fuel. So there is a reaction C2H5OH is ethanol. We already have learned that when there are two numbers or two atoms of carbon is there, we call it as eth. And there is OH is there, the functional group OH is there, so it is ethanol, which when get reacts with oxygen, it will give out carbon dioxide. So it's a fuel reaction. All right. So this was about the combustion. Now some day-to-day carbon compounds which goes through combustion are oils like saturated oil. So why we are calling oil as a saturated hydrocarbon? Why we are not calling it unsaturated? Because oil is made from what? Single bond. Means it is what? Alkane. Okay. So now there is a pic here. You can see that certain chemical compounds which we are using in our day-to-day activities burn out, or when they goes through combustion they burn out and gives in the result they give out certain flames, and those flames have colors, you know, which will tell you that certain element which goes through combustion is saturated hydrocarbon or unsaturated hydrocarbon. Now why via flames we are going to differentiate? How we are going to differentiate via flames that certain elements is saturated or unsaturated? So certain things happen where the carbon compound goes through complete combustion or incomplete combustion. So I have already told you when fuel goes through incomplete combustion, it gives out carbon monoxide, and that is in the form of black sooty flame. Likewise, whenever the complete combustion of carbonic compound takes place, it's give out blue color flame, and means that is pure flame, that is a saturated hydrocarbon flames. But in unsaturated hydrocarbons, you can see certain yellowish orangish flames which come out. This shows incomplete combustion of carbonic element. Now some elements are hazardous for the environment and some are not. Okay, while they are giving out yellow and orange flames, but yet they are not considered as so much harmful, just like carbon monoxide. So we will see certain examples which we use in our day-to-day life and they goes through combustion. So oil is considered as a saturated hydrocarbon, although it gives out yellow orange with some soot, less eco-friendly. Oil is refined from hydrocarbons, mainly alkanes. When burned, oil produces a yellow orange flame due to incomplete combustion and soot. Likewise, kerosene is a saturated hydrocarbon, still it gives out blue yellow flame, but its combustion is like it's give out blue flame, so it's like eco-friendly, right? It's a saturated hydrocarbons. Now when we talk about wood, it's a moderate to low eco-friendly. It gives out yellow orange with soot. So it is sustainable, but it is new. It is need to go to, if we want the wood to go through complete combustion, it is new, need to be harvested sustainably. Okay. Now about the tar. So tar is such unsaturated hydrocarbons, and it gives out soot, certain black soot it's give out, so it is not eco-friendly. It is unsaturated hydrocarbons like plastics. Now when we talk about the candles, it is saturated because it is made up of paraffin wax, which is quite eco-friendly. Okay. And that is why we make use of candles more and more. Then the charcoal is a saturated hydrocarbons. It gives out yellow orange with little smoke, and it is moderate to the environment. And we'll talk about the plastic. It's likely to the tar only, coal tar only. So it's a PVC, polythene. It will obviously gives out the toxic flames, and the toxic fumes will come out from the when we burn plastic. So it's an unsaturated hydrocarbons. Obviously, it will burn out with the black smoke and certain toxic fumes. So it is a no-no for the environment. So it was all about the combustion, where we have studied about certain examples of carbon compounds. How do they react when they get reacted with oxygen? So now you know that it is very important to know the chemical properties of certain carbon compounds, because if we are not able to, or if you're not aware of these chemical properties, we goes on using it more and more in our day-to-day life, and how do they harm our environment conditions. Okay, so that is why it is needed, or it is efficient, it is important to learn about the chemical properties. So first is clear to you, that is combustion. Now the next one is oxidation. Now what is oxidation? Oxidation refers to a chemical reaction in which a substance loses the electrons, typically involving the addition of oxygen or the removal of hydrogen. This process can occur in various forms in everyday, especially when carbon compounds interact with oxygen in the environment. So let's say if I'll say that combustion and oxidation is the same thing. Yes, combustion and oxidation is a kind of same thing, but combustion requires burning. Combustion involves burning, but oxidation can happen with or without burning. It's a heating process, but it does not always involve burning. It can happen with or without burning. That is a major difference between combustion and oxidation. Always remember that. So there are examples of oxidation such as respiration, digestion. These all goes through oxidation. All right. So in our common day-to-day life, there are certain biological processes that I just mentioned, the respiration and the digestion. For example, there is a glucose when goes through or react with oxygen, like the food which we eat, when it goes through or react with oxygen, it will give out carbon dioxide, water, and obviously the ATP. So this reaction does not involve burning, right? It does not involve burning, right? So that is why it is oxidation and not combustion. So and there are certain oxidizing agents which are involved, which helps in losing the electrons from certain elements and the addition of oxygen. They can do this process or accelerate this process speedily. Okay, so they can do the process speedily. So there are certain oxidizing agents such as potassium dichromate and the potassium permanganate. So these are the two oxidizing agents which are being mentioned in your NCERT, and these questions may also come separately, that name certain oxidizing agents which helps in losing the electrons from the element and helps in addition of oxygen in the element. So it is potassium dichromate and potassium permanganate. Always remember the oxidizing agents. Now when we talk about the third chemical property, that is addition reaction. Now what happens in addition reaction? It is simply the reaction in which the double bond such as alkenes or the triple bond such as alkynes is being converted into alkanes. Means if you want to have the result or the product you want that should be alkene, so we took place, or that reaction took place as addition reaction. Addition reactions are involved in converting the unsaturated hydrocarbons to the saturated hydrocarbons. Now how does this happen? We are going to see. There is an example, or there are certain types of addition reactions which are involved to convert the unsaturated hydrocarbons to saturated hydrocarbons. So first is hydrogenation, in which the involvement or addition of hydrogen takes place, like saturated, and the product is obviously the alkane only, alkane product. Okay, so example is ethene double bond unsaturated hydrocarbons. When get reacted with hydrogen, it gives out ethane, which is alkane. Now when we talk about halogenation, it's like addition of halogen. Halogen is like haloalkanes. You will form the haloalkanes afterwards, like chlorine, bromine, fluoro. These are some halogens. So the addition of halogens is known as the halogenation. And when we talk about hydrohalogenation, means you're getting the halogen plus hydrogen with it. Okay, so that is known as hydrohalogenation. Also can be possible due to addition reactions only. When we talk about hydration, so it's addition of what? Water, and it will give out what? Alcohol. So whenever, sometimes a question comes to you, what you're going to add on to give certain element which have alcohol to it. And if the reactant side is alkene or alkynes, you simply do the addition reaction through hydrogenation, halogenation, or this hydrohalogenation. Okay. And then we talk about oxidation, which we have learned in the previous chemical property. So we can do it by involving or adding the oxygen and converting the unsaturated hydrocarbons to the certain saturated hydrocarbon, that is alkene. So these are different types of addition reactions which do happens in addition reaction, which is being mentioned inside your NCERT. So now there are certain unsaturated hydrocarbons which we see in our day-to-day activities. So likewise, I have made these PPTs which are mentioning the examples which are in your NCERT textbook and the examples which you see common in the day-to-day activities. Okay, so we need to connect our science with the day-to-day activities in order to learn them. Okay, so why there is a need to convert the unsaturated hydrocarbons, that is double bond and this triple bonds, to form the this saturated hydrocarbon? Why there is a need? Why do we need this addition reaction? Actually, we need these reactions to convert the unsaturated hydrocarbons to saturated hydrocarbons. So there is an example where we used to convert these unsaturated hydrocarbons in certain oils. All right, we cannot consume the oils which are unsaturated, which are not refined properly, right? It is bad for our health, right? So in certain conditions, the addition reaction goes through certain oils. So you can see here, it converts the unsaturated oils to saturated fats like margarine and shortening the food industry. Sometimes we need to, or the food industry need to process their food so that it can be consumed after a while or after a month. So halogenation is the addition reaction which is being used for the food processing. All right. So these are the examples which will help you connect the dots with your day-to-day resources. So now we will learn about the substitution reaction. This is going to be probably the last chemical property. First we have done about the combustion, then we have studied oxidation, third one was addition reaction, the fourth one is substitution reaction. So in substitution reactions, mainly what happens, the substitution reactions means commonly occurs in saturated hydrocarbons and in aromatic compounds, means cyclic hydrocarbons, and they are used to substitute the halogen on their structured body, on their saturated hydrocarbons and in the cyclic hydrocarbons. So we will see that these substitution reactions majorly involve in industrial processes during the chemical synthesis, pharmaceuticals, pesticides, plastics. All this involves substitution reactions in which a substitution of halogen takes place in the alkane or the saturated hydrocarbons or the aromatic compounds such as like benzene and such as benzene. Okay. Now we will see certain examples where I can show you the substitution reactions. Now, number one is methane halogenation. The chlorination has happened, addition of chlorine. You can see UV light it's act like catalyst. These things which are present above the arrows, this is catalyst which can speed up the process. Then there is a halogenation of ethane. and then the halogenation of benzene, which is the aromatic compounds or the cyclic hydrocarbon. Okay, you can see there is addition of haloalkane. And then toluene. Yes, toluene is basically the very you can say very popular chemical compound which is used in the dyeing industry, where you need to dye up your clothes. Now toluene is involved. So in toluene, it's the aromatic compounds again, and then the nitric acid or to make it nitrotoluene is involved. So H2SO4 acting as a catalyst here. So catalysts are the compounds, or you can say the acids, which are involved to speed up the process, to accelerate the process without changing the chemical properties of the element before and after. Okay. So then there is, you can say methane, there fluorination is happening. So this was all about the substitution reaction and the chemical properties of carbon compounds. Now we are going to learn two major important important hydrocarbons, which is being mentioned in your NCERT textbook, that is ethanol and ethanoic acid. Their properties, their usage, their reactions are being mentioned. So we will mention their properties, reactions, so one by one. Okay. So first of all, we need to know where we are actually using the ethanol and ethanoic acid in our day-to-day activities. So ethanol, which is alcohol, obviously we have obviously learned that ethanol is being used as what? The common usage is fuel, right, in our automobiles. So it is being used as a fuel and solvent in alcoholic beverages and medicines, found in alcoholic drinks like beer, wine, antiseptic, fuel in some engines. And what about ethanoic acid? It's an acid, so it's been used as vinegar, or also used in food preservation and pickling, that is vinegar, industrial applications like plastics, production and solvents. Now we'll talk about the reactions which takes place in ethanol and ethanoic acid separately. So first of all, we will keep on comparing with the chemical properties of these hydrocarbons, compounds. So first we will go through combustion. So when ethanol goes through combustion or reacts with oxygen, carbon dioxide and water is involved. That is the simple equation which we have learned in fuel as well. So this ethanol is being used as fuel. Now for oxidation, when ethanol gets oxygenated, or you can say oxidized, it will form acetaldehyde. Acetaldehyde, you can see, you already know that CHO is the functional groups for acetaldehyde, and by using the potassium dichromate, which is what? Oxidizing agent, it can form the acetic acid as well. All right. Now there's a reaction, you can see this hot concentrated H2SO4 is being used to change this alcohol into what? The unsaturated hydrocarbons. So yes, ethanol is when goes through hot concentrated H2SO4, it can change into unsaturated hydrocarbon as well. So when reacting with the sodium, ethanol can change into what? It can form the sodium ethoxide and release hydrogen gas. This is an example of alcohol reacting with a metal. So there is an equation in your NCERT about the sodium, and this one. This is important. Also about the combustion. That's a major one. Okay. Now reaction with acid chlorides, so it will form acyl chloride. So yes, there is this one is also a major reaction, that is esterification. So you know what happens when alcohols reacts with the acyl chloride. Okay, the acyl chloride means HCl. It can form the esters. You know esters, you remember esters? These were the esters, the functional groups we have learned. Actually these what does these esters do actually? You know, these esters are known for what? To form perfumes, or they are the, you can know, they have a sweet smell and they are being used as in perfumes. Okay, so that is known as esterification, which is a major equations involved in the alcohols or ethanol. You can see here this ethanoic acid, and this is the ethanol goes through certain acid or catalyst, you can say, and ester is formed. You can see this functional group which is being there. So that is the one which involves in the esterification. So generally esters are the sweet smelling substance. These are used in making perfumes and flavoring agents. On treating with sodium hydroxide, further when we treat the esters with the sodium hydroxide, they can form an alkali. And then this reaction is known as saponification, which is used for producing the soaps. So whenever the ester goes through the reaction with sodium, or it is treated with sodium, it can gives a formation of soap. So now these were certain properties of ethanols. Now we'll talk about ethanoic acid. So what about in combustion? Combustion means ethanoic acid when goes through oxygen, it is exothermic reaction, means heat is being exit out and it burns out in the presence of oxygen to form carbon dioxide and water. Neutralization, you already know the balance situation, salt and water is being formed. So ethanoic acid reacts with bases like sodium hydroxide to form salt. This is a major reaction which is being mentioned in your NCERT. Covered up the larger portion of this chapter, and now only soaps and detergents has been left out with some NCERT exercise solutions. I'm going to meet you in the next part for this, and we will learn soap and detergents in the next part of this chapter and also solve out some NCERT questions. If you have any